Hello, class. Today we're going to go ahead and do our 5.1, 5.2 lesson. Today we're going to be talking about dilations and similar transformations in terms of what makes two shapes similar. The first thing you need to know is what is a dilation? And we say that a dilation is a transformation that changes the size of a figure, but not the shape. And we use that with a scale factor. Scale factors are represented by a lowercase k. And the scale factor will actually tell you whether a transformation specifically for our dilations is going to be a reduction or enlargement. If you've ever gone to the eye doctor and they put the eye drops in your eyes, they make your retinas open up. So what will happen is that's a dilation of your eyes. Your eyes actually open up, they get bigger. So in a reduction, we say that it has a scale factor that's less than 1. So what'll happen is you always look at your prime shape. And in this case, you see all the primes, right, are our little things that look like apostrophes there. And you take that measurement and you divide it by the measurement of one of the sides that matches up with it. So with this would be a reduction of 1/4. So the original shape has been shrunk down to 1/4 of its original size. Whereas the opposite is true. If we have a scale factor that's more than 1, then that means that we've had an enlargement. So again, same thing. If I look at my prime notation, you'll see that the prime shape has a side length of 4 right here. So then that means 4/2, that reduces to 2. So that means that that shape has become double the size that it was before. So if we go into just in general what we use scale factors for, if you want to figure out the size or length of the other shape after you know your scale factor, all you do is you multiply the pre-image by that scale factor. So in other words, if you know the length of your pre-image, multiply them all by the scale factor, you will get the length of your image. So in this example here with our trapezoid, you're going to see that we are given the scale factor of 1/2. So you're going to take half of each of those measurements as you move them over to their corresponding side. So 1/2 of 4 should get you 2. Now, because this is a trapezoid that has isosceles properties with the legs being the same, then that means 1/2 of 6 is going to get us 3. So each of these legs here are 3 apiece. And then last but not least, you can take the 8 that's down there. You're going to take half of it. And of course, 1/2 of 8 is 4. It's really easy once you get the hang of it. It's just multiplication. If you say out loud half of something, especially with fractions, it just makes it easier to intuitively know how to compute those without a calculator. So I'm going to give you all a chance to go ahead and try this one on your own. Go ahead and pause the video here and then just see if you can get the measurements. All right, so hopefully you use the scale factor of 2. And so all you do is you multiply each of these sides by 2. So you should get 6, 14, and 10. So hopefully you did that correct and you got it. So it's that easy. When we get into certain word problems, I know that always freaks people out. Like, oh my gosh, how do we, do them? I'm going to suggest you highlight or underline the parts that go together. So for instance, here you're going to see that you're looking through a magnifying glass. You have a 20 millimeter image of a diamond. We know it's 5 times bigger than the actual diamond. What is the pre-image? What was the size of it before the magnification? Well, we know that 20 millimeters is the image. The 5 times bigger part, that's your scale factor. And so what is your actual size, your pre-image? If we go back to the formula before, we know that the image equals the pre-image times the scale factor. So I'm going to just write that down, that my image equals the pre-image times the scale factor. Well, since my image was 20, we're just going to substitute 20 there. We don't know the preimage, so we're going to leave that alone, but our scale factor is k. So we could rewrite this as 20 equals 5 times the preimage. So then going back to algebra 1, all we have to do is divide both sides by 5. And then you're going to find that the preimage, 20 divided by 5, that gets you 4. So the original diamond was 4 millimeters. And you could do this with any word problem. You'll see word problems where you have, how many miles are in 1 inch for a map, for a legend. So you're just, again, using the relationship between those to solve those. And in general, if you want to find the scale factor, and I kind of showed you all this a little earlier, your scale factor of k is just the image divided by the preimage. So when I showed you all that at the top here, right, I took my measurement from the preimage, from the image here, and I divided it by the preimage. So that's how it got me the 1/4. Same thing over here. I took my image measurement of 4, divided it by 2. That got me 4 divided by 2, which was 2. So that's pretty much that for that part. So we can actually go ahead and apply it here. So first thing you're going to want to know is, how do I figure out which one's which? Again, use your prime notation to help you figure out that this is your image. Well, since I know that my scale factor is the image divided by the preimage, I'm just going to take the measurement from my image divided by the preimage. So 2 divided by 8, which, of course, you're going to want to reduce any fractions you're able to. That gets you 1/4. Now, what if it's on a coordinate plane? What if it's on a graph? Don't worry. As long as you know how to count, you'll be fine. So same thing. I'm going to look for my prime notation. That means that this right here is my image. So then I'm going to focus on the measurements that I can count on there to then find it in the preimage right here. Now, there are 4 sides on this shape, but I can only count on 2 of the sides. And that's because anything that's slanted or diagonal, you can't just count it. You need the squares to help you. So I would be able to count like the top here and say that that's a length of 1, 2, 3, 4, 5. Right? It's 5 across. So then I'm going to figure out how long it is across on the corresponding side here, which in this case on our image, on our preimage, it was a length of 3. So again, following the formula, scale factor equals the image divided by the preimage. So that's going to be a length of 5 over a length of 3. Now this fraction doesn't reduce, but because the fraction is a fraction that's improper, that means it's bigger than 1. That makes this an enlargement. Now, something I forgot to write down on the previous one, right? The previous one says state whether it's an enlargement or reduction. Well, that fraction of 1/4 is less than 1, so therefore this is a reduction. And we've honestly taken care of the hardest part of what we're doing today, because now we're going to apply the scale factor to ordered pairs and shapes. So now what we're going to do is we're going to do a dilation that is centered at 0, 0, which, if you remember, we also call that the origin. So if we want to dilate something that's centered at the origin, we just take the coordinates of our shape, figure, whatever it is. You just multiply each of the numbers in the coordinate by your scale factor. So you're going to see here in the formula, we do the x coordinate times the scale factor. We do the y coordinate times the scale factor. So I'm going to model on one of them here with y'all so you can see how that works. So in our figure here, we have a quadrilateral STVU, and you'll see that I've written out my coordinates there. So in the part up here, we want to find the scale factor of 2 and apply it to this shape. Well, since it's a scale factor of 2, that's my k. We're just going to take all of those points and multiply them by 2. So then S prime is going to be at -1 times 2, which is going to get you -2. Then you take 2 times 2, write your y coordinate there, then that's going to get you 4. So that's where S prime will be located. T prime, same thing. You're going to take those 2 3s, you're going to multiply them by 2. That'll get you 6 comma 6. Then when you go to v prime, I keep forgetting my primes. There we go. I'm going to do -1 times 2, which is -2. Then -2 times 2, which is -4. Then we go to u, and u prime is going to be -3 times 2, which is -6. 0 times 2, which is just a good old 0. So now we're going to plot all of those points onto our shape here on our graph. And you're going to see -2, +4 right there. That's going to be s prime. T prime, that's our good old 6 comma 6. So then that's going to be right at the edge there. So there's our T prime. Then we go to V prime, that's at -2, -4. So that'll be plotted right there, V prime. Okay, I know how to count, y'all. I said -2, but then I went to the wrong spot. So then there's V prime. And then last but not least, U prime, which is going to be at -6, comma 0. Now, to the best of your ability, or go grab a ruler that I have underneath the fan there, go ahead and connect your points. And you should have the shape, the image of the original one that has now been enlarged to twice the size. So this figure is twice as big. And you'll know you did it right because every spot where you have lines that are the corresponding parts, like here US and U prime S prime, they should be parallel. If they somehow look like they're not parallel, then you plotted one of your points wrong. So that's a nice little visual cue to help you. So if you want, go ahead and pause the video now and try example 7 on your own. Go ahead and apply the scale factor of 1/2 to all of those points. All right, so if you did it right and you took half of all of your points, your M prime should be at -2, comma 2. V prime should be at -2, -2. And P prime should be at -1, or sorry, not -1, +1, -2. So then plotting those points there, we're going to get M prime here, V prime here, and P prime there. And if you did that right, you can call yourself an MVP. Nice and simple. And again, same thing as before, I did show y'all that, okay, these lines should be parallel. So this one is indeed parallel to that one, and then the other two sets of sides are parallel to their corresponding sides. Now, if you look at example 8, you're going to see, oh my goodness, it's a fraction of a scale factor, and it's not a nice fraction. Don't worry about it. We are allowed decimals. So, like I promised y'all, this is the unit where you are going to be allowed calculators. So one way to do this is you could either leave your answer as an improper fraction, or using the decimals in your calculator, you can just punch it all in. So let me first tell y'all that the scale factor of 3/2 is the same thing as 1.5. So we take all of our points and multiply them by 1.5. Some of them will end in a decimal, some of them will end in a whole number. That's totally fine. We just need to know how to count. And when we plot them on the graph, if it's a decimal like 0.5, that just means we're halfway on a box. So you don't go the full box, you go half on the box. So let's go ahead and calculate this. So A prime, if I take 4 times 1.5, well, half of 4 is 2, so then that's going to get me -6. And again, that's just me doing it in my head. If you just punch it in the calculator, you're fine. -1 times 1.5, that's -1.5. Then I go to B prime. So then -3 times 1.5, that's -4.5. 2 times 1.5, that's going to get us 3. C prime, we're going to get a 1.5, comma 3, same thing. And then D prime, we're going to end up with 3, comma, -1.5. So now let's go ahead and plot these. So A prime will be at -6, comma, -1.5. So there's my -6 here. But then I got to go down 1.5. So this spot right there, halfway down the square, That's your A prime. Then I go to B prime. So that's going to be at negative 4.5. 1, 2, 3, 4 and a half. And then we go up 3. 1, 2, 3. So there's our good old B prime. Same thing with C prime. We're going to go 1 and a half. And then up 3. 1, 2, 3. Lastly, we got D prime. So then that's going to be 3 comma 1.5. 1, 2, 3. And then negative 1 and a half. So again, if you go ahead and connect these, I did it a little too curved. I was getting very ambitious there. There we go. See, I'm lucky I have the little auto snap tool. But go ahead and grab a ruler and connect those spots. Didn't work there. But you're going to see then that all of your lines, your little segments there, should be parallel to their original counterparts, their corresponding parts. Those are parallel to each other. These are parallel to each other. So then that means I know I did it correct. And thankfully for us, that is the end of the lesson. So go ahead and get started on the homework. Try to get through as much of it as you can. If you have questions, save them for me when you see me again. But otherwise, I hope you'll have a lovely day, and I will catch y'all later. Have a good night. Well, for me, have a good night. I'll catch y'all later. Have a great day.